Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with numbers 12, 13, and 14 on your homework here. This is in Unit 2. So this first one here says a 500 Newton force applied to a 200 kilogram rock as shown. Assume frictional coefficients of 0.3 and 0.4. Draw a free body of the rock. So, you've got this external force here. Let me change my colors here. Right, so we've got this external 500 Newton force, and it's important to notice right now that 500 newtons, there's no way it can lift that rock because that rock weighs almost 2,000 newtons. Remember, the gravitational force is mg and the mass is 200 kilograms. So it's not going to come off the ground. Put the gravitational force in, right, and then we have a surface in contact right there. Now that's going to give you a couple possibilities. A perpendicular possibility that we call the normal force, and a frictional force if the surfaces will allow. And apparently here the surfaces do allow because we have two frictional coefficients, 0.3 and 0.4. Now it's very common for me to word these like this. I usually will just give you two frictional coefficients and I expect you to know which one is the static and which one is the sliding or kinetic frictional coefficient. Now when you're dealing with, so part one, free body, that's what you're going to want to do. Right, now part two, when you're dealing with friction and it actually starts coming down to analyzing the problem. Oops, I'm trying to figure out how to scroll here. Oh, there we go. When you draw your free body, you should have a frictional force to the right. And, whoops, to figure out if it's going to slide or not, I would start by calculating the maximum possible frictional force. Right, and the max possible frictional force, remember, is the coefficient of static friction times the normal. So the first thing you're going to want to do is get the normal force. It actually says so right here. Find the normal. And you're going to get that by taking the sum of all forces in the direction of the normal. I'll call it the y direction for now. And that is going to equal 0. Important to realize why. 5,000 newtons is not enough to lift that rock. So for some, so the rock is definitely staying on the ground. So it's not going to accelerate up or down. So write this force equation and then get the normal force. All right, next we're going to decide if in fact that rock is going to accelerate. In order for that to happen, the x component of this 500 newtons, now if I were to draw that in the picture, it would be here. I'll just call it fx, and it is adjacent to the 35 degrees. That should give you a clue as to how to find it. Compare that to the maximum possible frictional force. If that force, the x component of that 500 newtons, is larger than the maximum possible frictional force, then you know it's going to accelerate. If it's not larger, if the maximum frictional force is larger, then you know it's not going to accelerate, and you're done with the problem. If it is going to accelerate, here's the good news. Then the frictional force, is equal to the coefficient of sliding friction times the normal force. So now you should have that. You should be able to find that value. And now if you write a force equation, sum of all forces in the x direction equals ma. And again, Captain Rod's rule of thumb, carets, left positive. That should give you an equation that will find the acceleration, if in fact it is going to accelerate. And I have no idea at this point, I just threw numbers at it. All right, so that should get you by that one. Ask if you're having trouble. Okay, next one. All right, this problem, and it looks super complicated, but it's not as bad as it might seem. All right, so for the first part where it says find the acceleration of the system, draw a free body of the system as defined like this. You're just going to pretend everything in green is one object, basically. You can put multiple gravitational forces if you want, but you don't have to. You could put one gravitational force and use a mass of 100 kilograms. That's the sum of the three. You could put one vertical normal. You could then put one frictional force, right? And then you can calculate the frictional force by normal times coefficient of friction, and then just write a Newton's second law equation to find the acceleration of the system. just a minute here. 80, 100, 1,000. Oh yeah, yeah, okay. I definitely believe it's going to accelerate. All right, so once you find the acceleration of the system, all right, now that acceleration is good for any free body that you draw in this picture. So as I move down here, we think about the other ones where it says to find the normal between A and B. So now what I would do is draw a free body either of this or this, doesn't really matter which. And let me talk about the free body of the BC part. All right, the 1,000 newtons does not directly act on B, okay? There's a normal between these boxes, between A and B, that normal along this surface, right there. There is going to be a normal acting on B to the right. And then you're going to have frictional forces along this surface. And you can calculate that frictional by calculating the normal at this surface times your frictional coefficient. Then you can write a Newton's second law equation for that system. And that will get you the normal force between B and C. All right, number 14 here. Okay, so this is one of these, incline problems tends to give people a lot of trouble. I just made a video on dealing with inclines. Watch that video. And to decide whether or not this is going to accelerate, right, that's the first thing you have to do. You have to, get your free body done. And I'll go ahead and put one force vector in. Right, the gravitational force is straight down. And hopefully you've seen my video about this or others. The component of that force that's in the, I'll call it the almost acceleration direction, or maybe acceleration direction, I'll say is this way. The reason I say maybe is conceivably there's enough friction in place to keep it from accelerating. And the frictional force is in the opposite direction acting on the car. So what you got to do is compare these. And if this force is bigger than this one, the maximum value of the frictional force, I should say, then the car is going to accelerate. So you're going to start by using this to calculate your frictional force, your max possible frictional force. And then if your max frictional force is bigger than this component of the gravitational force, you're done. It's not going to accelerate. If it's smaller, however, it is going to accelerate. But then you can go back and you'll know it's sliding. And you know to use this as your frictional coefficient. So again, I got videos about that. Ask if you're stuck. That should at least get you started. I don't want to do two more because basically it's your problem. So I hope that this gets you well underway in your homework. Have a great day.